energy! There are many ways to get it. There are many methods in order to get energy. And we use it every day. It's what powers our laptops. It's what charges our phones. It's our appliances in our kitchen every day so we can eat. It's what helps our schools grow. It's everything that we use every single day. But the problem with energy is that every single way to get energy has its own downside. Now, what are the downsides to some of the most popular ways to get energy out there, which are fossil fuels, or more specifically coal, which is the most popular, most common fossil fuel. That's the way the US uses fossil fuels, is using coal. The problem with coal is that, well, we all know about China. In China, the biggest reason for that terrible pollution problem in China is coal. Coal killed more than 4,200 people last year in China just due to coal accidents. The problem with nuclear power is that the Western media, they hype it up. A big disaster like coal, there are no big disasters like coal. It commonly kills thousands of people every year. But whenever you think about nuclear power, you all know about Chernobyl because it's a big disaster. It may have only killed so many people, and it may have only happened once in 20 years and then Fukushima later because of the terrible tsunami. Now, next let's talk about solar and wind power. Solar and wind power are awesome. I love solar and wind power. The problem with solar power is look at that roof up there. You know how much money it would cost to get solar power up on that roof? Between $10,000 to $40,000, depending on how much energy you want from it. Now, of course, this home is in direct sunlight, but other homes are not. The United States can just not use solar power to power all the corporations, all the cars, all the skyscrapers. There's just no way. It's not possible. And whenever we get rainy days, there's just is not big enough batteries to carry the amount of energy that we need for those few days. And solar energy does cost a lot of money. But solar energy is great, but it is extremely inefficient, as well as wind power. Now, let's talk about nuclear power. Guaranteed, still gonna automatically think about uranium nuclear fission. Now, nuclear fission and nuclear fusion are two types. I'll talk about nuclear fusion later. Now, nuclear fission is the only thing that we actually use on Earth. Now, nuclear fission is whenever we get two uranium nuclei, because uranium, when we first started looking for nuclear power, uranium was just cheaper. And that's why we decided to go with it, because in the first place, people are greedy. We're all greedy people. And the one thing that mattered to us most was money. So whenever we looked to get some nuclear power, we automatically went straight for uranium. The thing about uranium is that it has an insane amount of byproduct. But that's not what mattered to people at that time. What mattered was money. And what mattered was energy. What mattered was how amazing nuclear power is. Which of course it is amazing, but everybody hates it because, as I talked about before, is the Western media. All they do is they hype up about how terrible those few accidents that have happened because of nuclear power. And of course those were terrible disasters, but that only happened because of uranium. See, now nuclear fission, let's talk about how nuclear fission works. Nuclear fission is two nuclei that get split up nuclear fission is whenever you have a uranium atom that gets split into two separate nuclei, and that creates an insane amount of energy. Now, you want to know how insane the amount of energy is? It's pretty insane. One truckload of uranium can power an entire city for a year. Do you know how many truckloads of coal you would need to power an entire city for a year? Hundreds of thousands. Somewhere around there. What I'm trying to tell you is that there are always going to be byproducts to anything. Solar, we just simply do not have enough batteries. We just don't have enough batteries. We cannot carry the amount that we need. Wind power is cool, but it's also extremely inefficient. Imagine a world where we actually lived off of wind power. Imagine those no wind days. Imagine it wouldn't work. You can't store what you need for wind power like you can with nuclear power. Nuclear power is extremely efficient. The problem with nuclear power is the byproduct that comes from uranium nuclear fission, and that is plutonium, which is an extremely dangerous substance. Less than 1/1000th of a milligram inhaled by a human can cause lung cancer. One handful can destroy a city. Plutonium is the most dangerous thing to humankind. But what about the sun? Let's look at the sun. You see that sun up there? That sun. What about it? How does it have all this energy? How do we know? How does the sun have all this energy? Well, that's because it does something called nuclear fusion. Now, how does nuclear fusion work? How do we get nuclear fusion? How does nuclear fusion work? Why don't we use it already? If there's no byproduct of the sky, of the sun, then why don't we use it already? And that is it's kind of a complex question, but there is an answer to it. Basically, it's money. Basically, it's how hard a nuclear fission is to use. Now, my friends at Kurzgesagt, they have a great video on this, and I would like to share with you guys, and I'll show you it right now.
The sun shines because of nuclear fusion. In a nutshell, fusion is a thermonuclear process, meaning that the ingredients have to be incredibly hot, so hot that the atoms are stripped of their electrons, making a plasma where nuclei and electrons bounce around freely. Since nuclei are all positively charged, they repel each other. In order to overcome this repulsion, the particles have to be going very, very fast. In this context, very fast means very hot. Millions of degrees. Stars cheat to reach these temperatures. They are so massive that the pressure in their cores generates the heat to squeeze the nuclei together until they merge and fuse, creating heavier nuclei and releasing energy in the process. On Earth, it's not feasible to use this brute force method to create fusion. Scientists have invented two ways of making plasmas hot enough to fuse. The first type of reactor uses a magnetic field to squeeze a plasma in a donut-shaped chamber where the reactions take place. These magnetic confinement reactors, such as the ITER reactor in France, use superconducting electromagnets cooled with liquid helium to within a few degrees of absolute zero, meaning they host some of the biggest temperature gradients in the known universe. The second type, called inertial confinement, uses pulses from superpowered lasers to heat the surface of a pellet of fuel, imploding it, briefly making the fuel hot and dense enough to fuse. In fact, one of the most powerful lasers in the world is used for fusion experiments at the National Ignition Facility in the US. These experiments and others like them around the world are today just experiments. Scientists are still developing the technology. And although they can achieve fusion, right now it costs more energy to do the experiments than they produce in fusion. The technology has a long way to go before it's commercially viable. And maybe it never will be. It might just be impossible to make a viable fusion reactor on Earth. But if it gets there, it will be so efficient that a single glass of seawater could be used to produce as much energy as burning a barrel of oil with no waste to speak of. This is because fusion reactors would use hydrogen or helium as fuel, and seawater is loaded with hydrogen. But not just any hydrogen will do. Specific isotopes with extra neutrons, called deuterium and tritium, are needed to make the right reactions. Deuterium is stable and can be found in abundance in seawater, though tritium is a bit trickier. It's radioactive, and there may only be 20 kilograms of it in the world, mostly in nuclear warheads, which makes it incredibly expensive. So we may need another fusion buddy for deuterium instead of tritium. Helium-3, an isotope of helium, might be a great substitute. Unfortunately, it's also incredibly rare on Earth. But here, the Moon might have the answer. Over billions of years, the solar wind may have built up huge deposits of helium-3 on the Moon. Instead of making helium-3, we can mine it. If we could sift the lunar dust for helium, we'd have enough fuel to power the entire world for thousands of years. Okay, maybe you think building a mini-sun still sounds kind of dangerous. But they'd actually be much safer than most other types of power plant. A fusion reactor is not like a nuclear plant, which can melt down catastrophically. If the confinement failed, then the plasma would expand and cool, and the reaction would stop. Put simply, it's not a bomb. The release of radioactive fuel like tritium could pose a threat to the environment. Tritium could bond with oxygen, making radioactive water, which could be dangerous as it seeps into the environment. Fortunately, there's no more than a few grams of tritium in use at a given time, so a leak would be quickly diluted. So we've just told you that there's nearly unlimited energy to be had at no expense to the environment in something as simple as water. So, what's the catch? Cost. We simply don't know if fusion power will ever be commercially viable. Even if they work, they might be too expensive to ever build. The main drawback is that it's unproven technology. It's a $10 billion gamble, and that money might be better spent on other clean energy that's already proven itself. Maybe we should cut our losses. Or maybe, when the payoff is unlimited clean energy for everyone, it might be worth the risk.
And don't forget to donate the Trial for Energy to help this become a real possibility to have nuclear fusion in our lives someday.